separated from every other muscle by a connective tissue layer called fascia. So the outer layer of a muscle is a connective tissue layer that separates one muscle from the other. Pericardial sac, pleural sac, or the peritoneal sac, all of them. Around the heart, the lungs, and the other organs. All of these sacs are connective tissue that connect tissues one to another. Tendons connect muscle to bone. Ligaments connect bone to bone. So connective tissues are always connecting, and that's why there isn't one piece of connective tissue in your body that isn't in some way connected or touching another piece of connective tissue, which is touching another, which is touching another, and unless you actually cut a piece of connective tissue, the entire thing is joined together. Your entire connective tissue. So support and movement bones. So you cannot have support, you can't have a shape. If we didn't have bones, we'd be a round ball of muscle. Just a perfect round ball. And the only way you can do it is to flex and relax and bounce over the ball. And eventually we all end up with bodies doing something. How do you do it? Maybe our balls. So, bouncing little balls of muscle, we are not. We're not So, storage, fat is connective tissue. So we store extra fuel. So we have too much fuel in your body, you go throw it in the fat cell, store it there. Cushioning and insulation, fat, transport blood. Blood brings gaseous exchange. Gaseous exchange means that we turn acid into water, and that means we have and then, of course, protection, cells of the immune system. All white blood cells are our immune system. That is the immune system. The immune system is white blood cells and a couple of fibers, but basically white blood cells. So that's the function overall. When we look at type of cells, we have three types of cells. Or pardon me, there's more than three types. But we're going to look at these descriptive terms of cells. First of all, a site, C-Y-T-E. So look at glass cells, sites, and glasses. A glass cell is a cell that builds matrix. It's building the matrix. It's a young cell that's building matrix. Once the matrix has been made, surrounded by matrix, the cell lives within a lacuna, right? So the cell is in the lacuna that it is made out of the matrix. This cell living in the matrix now becomes a site. So what started, say, it was a cartilage cell that was making, started out as a chondroblast, and it made the matrix of the cartilage. It became engulfed by the matrix in a lacuna, and now it's a chondrocyte. Now, because there are no class cells in the cartilage, you won't find a chondroblast, but a class cell breaks something down. So in a bone, let's go to bone. In a bone, a class cell would be an osteoblast. During a blast, it's a suffix. Okay? So osteo, the osteoblast is using the suffix, like a bone building cell, right? That's what it is, bone builder. So osteoblast. An osteocyte maintains the matrix. So it's a bone maintenance cell. And osteoblasts, and osteocytes are the same cell. And they come from this exact same place. Oops. But a class cell, different cell altogether, right? Not the same cell, didn't just go from young to old, right? Didn't go from building to maintaining. It's a completely different cell. And it exists on the internal side of the bone. And it eats bone, right? It releases acid, splashes the bone with acid. The calcium and phosphate start to come off the bone. Enzymes absorb that and use it in our bodies. So, glass cell builds, a site maintains, a class breaks it down. Remember, in an exam, look maintains, and class needs to break down. But if it's a chondrocyte or an osteocyte or a fibrocyte or a myocyte, right? These are different. They're different cells. Myocyte is a muscle cell, right? So look at what is the prefix as well, so that you can be sure that you answer the question correctly. So they're connective tissue cells. These are the connective tissue cells. And you would find all of these cells in areolar tissue, but it's the only connective tissue where you find them all. So within areolar, you will find fat cells, you'll find mast cells. Mast cells are part of the immune system, and they are, we don't now, but they're what's called MALT, mucosa-associated lymphatic tissue, meaning that it's a first line of defense for cells that exist within mucous membranes, and they attack and things that cause or enter other parts of the body. White blood cells, of course, respond to your infection, macrophages, phagocytize, and they consume, right? And macrophages, we have fixed and wandering macrophages in the connective tissue, so they keep moving around. These are the big killers of our bodies. These are the cells that are big bad cruisers. They cruise around, they eat anything they come up and eat. You don't have a knee antigen, then it's going to eat you. And so, knee antigen or die. Show me the papers. Okay, first of all, so macrophages, and then undifferentiated mesenchyme. You've all heard of stem cells. Stem cells are cells undifferentiated. That's why they're important. The word undifferentiated means they haven't been given a task yet. They can be anything they want. They can be any type of connective tissue. But once they're differentiated, then they go off to be a specific thing. And you are now going to become an osteocyte. So that's it. It goes off and becomes a bone cell. And your chondrocyte will go off and become a cartilage cell. So once it's differentiated, it's no longer a stem cell. Right? So undifferentiated mesenchyme is stem cell material that can become anything. And we'll talk a lot more about that in the class. So, what is the ground matrix made of? It's made up of two things. So ground matrix is made up of two things: ground substance and protein fibers. We talked a bit about this in lab last week. The three types of protein fibers: collagen, reticular, and elastic. Collagen, strong, tensile fibers. Elastic connective tissue, and we saw that it looked like coiled springs. Right? You can stretch those springs out and they'll point back in. Reticular, very fine collagenous fibers. So collagen and reticular are both collagen fibers. It's just reticular is very fine collagenous fibers. Right? So that's the difference between the two. But still collagen. So these are the three protein fibers. You can have all three, like areolar tissue, or you can have one, like collagen bone. So when you look, you can have one or all three, or parts of the in tissue. Now, when we look at, there's three kinds of things that we can look at. We can look at liquid, blood, and plasma is the matrix, and that's 90% water. So we can basically say in blood, plasma, and water. If we look at bone, we can say that it's calcium phosphate, which is common. Water, concrete, in the middle, gel. The amount of gel depends on some things. Two things in particular. We're looking at the fact that polysaccharide is a complex sugar. Sugar is what we're using. Sugar. So the body resist friction really well, right? So that's what's produced. So this hyaluronic acid is a very viscous fluid dense with sugars, so it's like a syrup, right? It's a good lubricant. So this lubricant is throughout the joints of all the synovial joints of our body, so that when the bones move, it's like oil in your engine to keep the pistons. The piston rings are wearing out against the walls of the piston, right? Exact same idea. We're lubricating the joint so that the bone moves without friction. Then we have what's called protein and polysaccharides. Protein part attached to hyaluronic acid, which traps the bone into water. So let's see if I can draw a picture of this for you. And hopefully you guys can see it. That's not very good. I know there's no picture. Yeah. There we go. It's kind of fantastic. Don't worry about it. I'm going to explain it to you. I like to glycan molecule as a tree, as a little evergreen tree. And you look at that hyaluronic acid molecule, and it's like a pill, right? It's like this kind of shape. What happens is that at the base of the tree, where the stalk of the tree would come out, it gets stuck to the oblong shape of the hyaluronic acid molecule. So what you get is it looks like a tree with this kind of oblong thing sticking off the bottom. So it looks like a big tree. And the idea is that when they come together, when they join together, they trap water. So we've got this group of sugar and we've got water. And this sugar and water forms the gel. Now, when they come together, this forms what is called a proteoglycan aggregate. That's what this is called, a proteoglycan aggregate when they come together. And how do they come together? So the proteoglycan aggregate comes together because of chondronectin in cartilage, osteonectin in bone, and fibronectin in fibrous connective tissue. So nectin is the glue that holds them together, right? So nectin is this glue that holds the proteoglycan and the hyaluronic acid together, which forms a proteoglycan aggregate, which, because it's this complex sugar with water, gives us the gel-like appearance. It gives us compressibility. So the more compressibility that a connective tissue has, the more proteoglycan aggregate it has. The less compressible it is, the less proteoglycan aggregate that it has. Remember, you either have a liquid matrix like blood, you have concrete matrix like bone, or you have some level of proteoglycan aggregate. So if you're not bone and you're not blood, you're something else, then this is your matrix, right? A percentage of it, along with one of the 3 protein fibers, either collagen, reticular, or elastic. So that together, everybody, either water, concrete, proteoglycan aggregate, or collagen, reticular, elastic fibers. How they come together is going to determine the matrix. And the matrix determines the function of the connective tissue. This is the kind of thing you're going to get tested on in lecture. Not about whether you can identify the connective tissue, but if you can explain matrix, right? You understand matrix. Can you apply it? Can you see how matrix affects function? Those are the things that you're going to get tested on, right? So in this, it's completely different than lab. Yes?
Just one, like it has to be like one fiber, one protein fiber, and one.
No, they can be multiple fibers, yeah. Or multiple fibers in the tissue. You get areolar tissue, it has all 3 fibers in it. And you get, say your ear would have collagen and elastic.
Yes.
So it can only be one fiber, I mean, it can be either fiber, all of them or one, but only one ground substance, or?
Well, generally speaking, yeah, you either have mineral ground substance, as in bone, you have a water ground substance, or you have a proteoglycan aggregate substance. Yeah. Right. Yeah. And when you think about something like areolar tissue, which has a lot of proteoglycan aggregate, part of proteoglycan aggregate is water. Right? Because the proteoglycan and the hyaluronic acid, proteoglycan being a protein, traps water. It attracts it. So because it attracts it, it comes to it and holds it in place. So it's protein, sugar, and water is what the proteoglycan aggregate is. Right? Everybody feel comfortable with that? Like, how did I ever want to learn that for? No, yes, you did. Mesenchyme, yes? What actual pages? It should be in the first 2 chapters of the text. Yeah. Tissues, it would be in the tissue area, the histology area of the text.
Chapter 3.
So we talked about embryonic tissue having 3 layers: mesoderm, ectoderm, endoderm. And it's from the mesodermic layer that we get all connective tissues. And so mesoderm of the embryonic stage, so forms primarily from mesoderm. So if you're a mesomorphic person, you have a lot of muscle, you have a lot of tendon, you have big bones. You're a person that is of connective tissue, right?